So let me introduce myself formally. My name is Akshit. I'm a senior solutions architect at DigitalOcean. So we all know AI adoption is exploding, but the main challenge is to use AI workloads or AI inferencing at scale without managing the GPU and also keeping the cost in control. So today, what we are trying to focus on is serverless inference. It is a modern approach that helps you run AI workloads without managing the infrastructure and also keeping your cost under control. So in this session, we'll also talk and see how you can deploy LLMs, text to image models using inference. And by the end of the session, we will understand and learn how you can have a production ready AI workload. Thank you. AI workload running on any of the solutions without any kind of issues with the management of infrastructure and also having very efficient cost. Okay, let's focus on the agenda as well. So we'll start with a little bit about the traditional infrastructure, how server-based inference works. Then we'll talk about serverless inference. We'll also understand why you should be using serverless, the benefits and use cases. Then we'll go with the architecture, a little bit of explanation of how the flow works. And then we will follow with the gradient implementation, followed by live demo Q&A. Okay, so as I mentioned, let's first talk about the traditional AI challenges. So earlier or initially, what we had to do is for running any kind of AI workloads, it was essential to for any of the model to be run on the platform. It was very important to have your own infrastructure setup done. So it is essential that people run their own infrastructure, set up their GPU, take care of the full life cycle of the infrastructure management. And then on top of that, the DevOps or the engineering team were also responsible for all kind of availability, reliability, scaling, monitoring, and all of those, right? So this was an additional and a lot of time consuming task, plus a lot of manpower or man resources required for it, right? Now, this problem that I'm talking is only about the open source models that are available. Now, if we talk about the proprietary models, let's say from OpenAI or Anthropic, they come with their own additional model endpoints, plus also they have their own billing system. So that adds a lot of vendor management as well. So to sum it up, the problems were managing the infrastructure, the GPU management, the vendor management, the scaling and the management of the infrastructure, right? So these were all the traditional overhead or the traditional issues that we had. So I think so serverless inference, the basic or the most important part of serverless inference that it does not require any kind of infrastructure setup. So most importantly, you do not have to worry or you do not have to get into the headache of the infrastructure setup or the GPU management. You can directly start using inference or the applications directly or the models directly. So no management of the infrastructure, no scaling logic. So you only pay for the inference or the tokens that you use. So let's say you are using serverless inference and you are using one of the models. You only pay for the time you are requiring or using the tokens, and you also only pay for the compute used, the millisecond of compute that you use. Okay. So as you can see, the key points: no server provisioning, clusters or capacity planning. You only pay per use, and you can always iterate and build newer versions or newer releases as soon as possible. You can try and use multiple different models without getting into the overhead of setting up the infrastructure at the backend. Now let's also talk about the benefits, features of serverless inference. I will start with the zero infrastructure management. I think I have already iterated a couple of times, right? The biggest problem, the biggest advantage is you eliminate the whole task of infrastructure setup. And anyone who is working on infrastructure would very well understand how difficult and challenging it is. Building is one part of it. The another part is the maintenance of it. So let's say you have built an infrastructure today with all the requirements, say from the procurement of GPUs, all the networking, all the wiring and everything is done. On top of that, you will always have to manage it. You have to monitor it. You have to administrate it. You have to take care of the security patching, updates, new models that comes up. You have to get those installed, right? So this is all the infrastructure headache we do not have with serverless inference. Automatic scaling. So irrespective of how spiky or viral loads that you have, it always takes care of the scaling at the backend. The elastic scaling happens at the backend in milliseconds, and you do not have to worry about it. So whenever the traffic increases, it can handle the load, and when the traffic reduces, your cost goes down. You do not pay for, you do not have to pay for the infrastructure at the backend when the demand is low or the traffic is low. Cost efficient pricing, again, as it is mentioned here as well, pay per inference. So very important to understand is, let's say you have a GPU running for your models and you're running your models on a GPU. You have to use a consumed GPU throughout the day, 24/7. If it is running, you are paying for it. However, when it comes to inference, you are only paying for the inference or the tokens that you are using. You are only paying for the millisecond of compute you are using. Let's say you are doing an LLM call or the API call. So the API call is done whenever, only then you are paying for it. Okay. Next follows is the simplified model management accompanied with unified access key. So this is all under one umbrella, one roof. So you are creating a model access key. We will see that in the demo as well. So you are creating a model access key within one screen or one UI, and from there itself, you get the access to all the models available from various different vendors and providers, right? So you do not have to hover across different providers or different screens or different web pages, etc. So you have one unified screen, one unified management, and on top of that, it also adds the unified API scope. So you create one model access key that helps you authenticate to the API endpoint. And that API endpoint gives you access to numerous different models and model providers. And finally, and the most important is faster time to market. So imagine everything that we talked about, all the benefits that we talked about. Most crucial is to save the time. So all the time that you are saving in creating the infrastructure, deploying the infrastructure, doing your testing, model training, model tuning, you are saving all of those. And rather than spending more time or your DevOps time, engineering time in infrastructure, you are saving and using that for creating your application. So you can have multiple iterations, experimentations on your model, and you can have it maybe with beta version or version 1 release, version 2 release, and you can directly go to the customer who needs those products, and you can directly test with them. So that is the biggest advantage. So you can have multiple releases, you can go to market, you can see the feedbacks and keep improving your products rather than wasting or spending a lot of time on the infrastructure setup. So now why we use DigitalOcean Inference? So everything that we talked on the last slide about the benefits is all true here. First one is unified access key for all models and vendors. We will see that in the demo as well, but you only create one access key. That access key gives you access to the model endpoint, and that model endpoint gives you access to all the model providers and models available, right? Single API endpoint. So irrespective of which model you are using, you only have one endpoint to call, and then you can on your syntax change whichever model you want to use, right? So simple management, easy integration across models. Centralized billing and usage monitoring. Again, if you have multiple applications, you are using multiple different models, you do not have to hover across different models or different web pages to see that. You will get one centralized billing. All the DigitalOcean products that you are using, including different models, it will all be built together in one screen. So you do not have to keep a check or eye on different payment gateways or payments and PDF files to keep track of the billing as well. Cost advantages for many workloads, yes. So DigitalOcean is already partnered with a lot of providers, right? So irrespective, as a single user or individual user, you might have to pay a little extra. However, DigitalOcean being already partnered with maybe Anthropic or DeepSeek or Alibaba, you get a better pricing there. On top of that, you can always get better discounts being on how bigger or how better customer you are. And then you are also supported with the major models from OpenAI, Cloud, and Llama, etc. Now, this is a little bit of explanation, a very over top view explanation of how the Gradient AI platform works. We will see again in the demo while we're creating a generate access key. So this access key is required for the authentication to the API endpoint, the HTTP request that goes to the API endpoint. You can see the API endpoint address. inference.do-ai.run/vv. So this is the inference endpoint. From here, you get access to the various models, and then you can integrate it with your application. We will also be showing that as a full-fledged working application, and then you can connect it to clients and SDK. Now, before we get into the demo, I'll just show you what are the things that we will be covering. First thing, we will go to the DigitalOcean console, create an access key. This will give you access to the model endpoint. Then we will go to Postman and do the model and or the API calls using Postman. I'll show you various different API endpoint calls. Then we will show inference in action. I will do the API endpoint calls to show you how the LLM works, how you are getting the output of it out of it. And I have also developed a full-fledged application using serverless inference using the file.ai model. Anyone here has heard about the file.ai model, text to image models or speech to text to speech models? Anyone? Okay, I see a few hands. Good. So we'll be using that. And I have a full-fledged application. I'll show you a little bit on the code as well, how it is developed, where the application is integrated. And there's one more interesting part, which is model comparison, where you can compare different models and see which is the best suited model for your use case and for your functionality. So let me start. Yeah. You guys can see my screen? Okay. So this is my DigitalOcean console. On the left-hand side, you can see all the services DigitalOcean has to offer. I'll not get into those details. I'll first go to agent platform. Here you can see serverless inference. Let it load. I hope my internet is not disconnected. Okay, perfect. So serverless inference, this is what we have been talking about all through. You see a model endpoint details. I'll show you that. The first thing that I want to show you is model access key. There's one already created, but we do have option to create more. So I will create one for the sake of everyone's view. So let's say I given it a name CloudConf. Here you can see the list of all the models that are available. All these models can be authenticated and used. And you can also see the transparent simple pricing for the input token per million and the output token per million. So let's say if you're trying to or you plan to use Open AI GPT OSS 120 billion parameter, this is the input token and the output token price that you see here, right? And this is the huge list of all the models that are available and integrated with the serverless inference on DigitalOcean, right? So if I click on add model access key, you will see the security key for this particular model access key. Now you have to use this to authenticate to the API endpoints, right? Now API endpoint, here is an example on the right hand side that you can see. These are the various different syntax that you can use for chat completion, and this is the syntax that is mentioned here. For this particular demo, I will only be using curl. I'll be using Postman for the endpoints. And here is the list of all the models that you see here. So let's say Open GPT OSS. This is my endpoint URL. Is it big enough? Okay, perfect. So this is my chat completion is the endpoint. Here is the barrier token authentication and the model name is listed here. The only thing that changes every time you choose a different model is the model name, right? So if I select Llama, the name changes here. So that's the only part of the application code that needs to be changed, right? So we have some idea here. Let me just jump into Postman and show you all of these in action. So first thing first, this is a GET request that I'm sending to the API endpoint. I already have the authorization token added, bear token, and this is my authorization key that I have added. And this is the endpoint GET request that I'll send. If I send this GET request, I should be getting or seeing the list of all the models that are available, right? We do have a documentation that explains all of this very well. So this is, let's say, the one that we ran right now, the GET request to this API endpoint that returns the list of all the available models. That is exactly what we see here, the list of all the models, Alibaba, Quen, Anthropic, and the list is huge, long list of it, right? So this is one endpoint call that we wanted to show. Next, I will also show you the chat completion, the exact same one that is mentioned here in the examples, right? So the chat completion, what are we doing? We have again authorized using the barrier token. If I go to the API endpoint, this is my API endpoint, and I send a post request to it. The content is the token that I'll be using, which is what is the capital of France. And I've also set up parameter of max tokens, and I should be seeing an output very soon. And the output says the capital of France is Paris. So this is what we have here on chat completion. Next thing is, I also wanted to show you the use of FAL AI here, and then I'll show you with the full application as well. So this is the model that I'm calling FAL AI's Fast SDLX. This is one of the model that is used for image generation and a quicker image generation. Again, this will be a post request to this endpoint inference.do-ai.run async invoke. Now, when I send this command or this API request, I will get a request ID. Using that request ID, I should see file output. Here, I will just change the request ID and I should get the output generated. So this is the URL where I have the output. Oops, sorry. So this should generate the image of a dog playing with a cat. That is the exact command that I entered here, right? A dog playing with the cat. So now that we have seen this on Postman, just showing you the API calls, I want to show you a full-fledged application as well. So this is a file image generator application that I've hosted on GitHub. For the sake of time, I'll just quickly show you one part of the code just to explain you how the integration works, how you can use it. So here you can see on the application, this is where I have my base URL of the inference URL added here. This is my model access key authentication that will happen. Is it, should I zoom it? Okay. And this is my API endpoint that needs to be called. This is the model ID or the model that I am using. This is the part that I wanted to show you. And then I will go and show you the actual working application. So this is all hosted on my app platform, DigitalOcean's app platform. Let that load and the application should be up there. So this is the application file image generator. So this is the image or the application that we were talking about earlier. If I go ahead and select the inference step, this is just few of the customizations that I've added to the application. And let me search something which is already there. Steampunk airship flying through clouds at sunset. So it will generate something similar to what we have added as the prompt. And this is what you see. So this is all an application developed using the FAL AI's model, which is at the backend using serverless inference from DigitalOcean. And we are all doing it from one model access key and one API endpoint. Okay. This is all on the demo. One last thing I also want to showcase is the model playground. So model playground is really interesting for anyone who is very new to AI world and they're still trying to understand which is the best fitted or best suited models for them. So this is where you can compare various different models and see which is the best suited one for you. So let's say I've selected a Llama 8 billion and I ask what are the 7 wonders of the world. Okay. And I want to compare it with any other model, maybe let's say DeepSeek. This is 70 billion, right? And I add the same here. So you can see the difference in the way the answers are coming or the response are coming. And then accordingly, you can choose which is the best suited one. Let's say DeepSeek is a thinking model or reasoning model, right? So it takes a little bit longer to think and reason and give you an answer. This answer is a little bit longer and lengthier. So depending on your use cases, you can select which is the best suited one. This is all from the demo. There's one last slide that I wanted to highlight, which is essential to wrap up the whole serverless inference to understand the best practices. Now that we know what serverless inference is capable of and how you can save money, it is very important to do a good model selection. When I say good model selection, when you are starting new, just try and do some experimentation with a smaller parameter like 7 billion, 13 billion models. And when you are ready to go production, go for 80 billion or more kind of a parameters there. Auto scaling, you have to set reasonable concurrency limits. So any DigitalOcean does handle thousands of requests per second automatically, but you are responsible or you should be responsible for taking care of the max tokens used or number of tokens used per minute or per second. So you can always have those thresholds or those limits set. And then always take care of the monitoring, track token usage, error usage, log every request for debugging so that you can have a good idea about all of this that you are using, right? So this is on serverless inference. One last thing I want to wrap up with is now this is a service provided by many different providers. For the recognition and awareness of everyone, this is the exact same thing that AWS calls as Bedrock. GCP calls as Vertex AI, and AWS or Azure calls it as AI Foundry, and DigitalOcean calls it under the Gradient AI platform. So serverless inference is one of the offering under the Gradient AI platform. Just to wrap up, this is just a recap of where you can see or where you can use serverless inference. You go to agent platform, serverless inference, and create the model access key. And our showstopper for today is the one key concept where you create one model access key and that gives you access to different model providers from different vendors, Llama, GPT, Cloud, Mistral, right? That is all. And this is where you can scan and get in touch with the DigitalOcean team. We do have a booth outside. If there are questions, please drop down, meet us, talk to us. I'll be happy to answer your questions and help you guys. And you also get $200 credit to try DigitalOcean. If you are already using and you need expert guidance, you can reach out to the solutions architect team. I am one of them. And also you can reach out to the sales team. This is the last part where it is all mentioned about all the resources that I have used to create these slides. You have all the documentations very well thorough available. That's all from me, guys. I hope this was informative and helpful. Thank you so much for your time.